Here we will see a typical problem. It might be some confusing, but this is a simple problem. An elastic air balloon having a diameter 30 cm is attached to base of a container partially filled with water at 4 degrees centigrade is shown in the figure. So here the figure is here, and first let me read the question. If the pressure of air above water is gradually increased from 100 kilopascal to 1.6 megapascal, will the force on the cable change? If so, what is the percentage change in the force? Assume pressure on free surface and diameter of the balloon are related by P is equal to C into D power M, where C is a constant and N is equal to -2. Weight of the balloon and air is negligible. Assume water is incompressible. So the question given here is, there is this closed container and the liquid is filled, and there is a air balloon inside the liquid. It is attached to the string, and on the free surface of water there is air of pressure 100 kilopascal initially, and that is increased to 1.6 megapascal. So the question is, if that is increased to 1.6 megapascal, does the tension in the string changes or not? If changes, how much percentage does it change? That is the question. First let me write the given data. Initial pressure is equal to 100 kPa. The final pressure is equal to 1.6 MPa. So it is 1600 kPa. So this is the data given, and the initial diameter is equal to 30 centimeter. It is equal to 0.3 meter. So how do we know if the tension changes or not? We have seen that free body we have seen in last video that weight will be acting downwards, buoyancy force will be acting upwards, and the tension will be away from the body. So this is T. Tension is equal to tension plus W is equal to Fb. So tension is equal to buoyancy force minus weight of the body. So here it is given that the weight of the balloon and air in it is negligible. So we will neglect the weight of the balloon and also air in the balloon. So if we neglect this, tension is equal to buoyancy force. So we can finally conclude that if buoyancy force changes, the tension also changes. So how do we know if buoyancy force changes or not? It is said that the pressure is increased and pressure and diameter are related in this way. So if pressure is increased, the diameter also changes. If the diameter changes, it means that buoyancy force is equal to density of fluid, acceleration due to gravity, and volume of fluid displaced. So if the the diameter of this balloon changes, the volume of fluid displaced also changes. So buoyancy force also changes. The first question is, will the force on the cable change? Yes, it changes. That is because the diameter of the balloon changes, so that the buoyancy force changes and the tension also changes. So how much does it change? We will find it now. So first we need to find the change in buoyancy force. If the buoyancy change in buoyancy force is equal to change in tension. So here P1 by P2 is equal to D1 by D2 whole power n, and also n is given as -2 here. So P1 is 100 kilopascal and P2 is 1600 kilopascal, which is equal to diameter is 30 centimeter, initial diameter, and final diameter is, we need to find that. So 1 by 16 is equal to, so we can write it as D2 by 30 whole square. And now D2 by 30 is equal to the square root of 1 by 16 is 1 by 4, and D2 is equal to 30 by 4. So 4 7s are 28 and 4 5 are 20. So 7.5 centimeter is the final diameter of the balloon, and if you convert 7.5 centimeter into meter, it is 0.075 meter. So firstly, initial buoyancy force Fb1 is equal to density of fluid, acceleration due to gravity, and volume of fluid displaced in first case. So density of fluid, it is given as water. So consider 1000 kg per meter cube is the density of water. Acceleration due to gravity is 9.81. what is the volume of fluid displaced? It is entirely submerged. The balloon is entirely submerged. So what is the volume of fluid displaced is equal to volume of that balloon. So as it is a sphere, it is 4 by 3 into pi r cube or r1 cube initial radius. So 1000 into 9.81 into 4 by 3 into pi into radius. Initial radius is initial diameter is 30 centimeter. The radius will be 15 centimeter. So it is 0.15 meter. 0.15 meter. Okay. If I solve this, we will be getting the buoyancy, initial buoyancy force as 138.69. 138.69 newtons. And this is the initial buoyancy force. And what is the final buoyancy force? The volume of the balloon has been changed, so the displaced volume will change, and as the displaced volume changes, buoyancy force changes. So density of fluid, acceleration due to gravity into volume of fluid displaced in final stage. So the density of the fluid is 1000 kg per meter cube into 9.81 into volume of fluid displaced 4 by 3 into pi into r2 cube. So 1000 into 9.81 into 4 by 3 pi into r2. What is the value of radius in the second stage or final stage? It is 0.075 is the diameter, divided by 2 is the radius, whole cube. So this will yield a value of 2.167 Newton. So this is buoyancy force in first case, which is initial tension. Due to the increase of air pressure above the water surface, there is final buoyancy force, which is 2.167 Newton. This is tension in second case. So percentage change in tension is equal to T2 minus T1 divided by T1 into 100. So final tension minus initial tension divided by initial tension into 100 gives us the percentage change in tension. T2, it is 2.167 Newton minus T1. So T1 is 138.69 divided by 138.69 into 100. So this will give us a value of minus 98.4%. So what it is indicating, as the pressure above the water surface increases, the tension in the string decreases. So this is a very good problem, and this is also very simple, but it looks like a very difficult one. If the basic concepts are clear, that will be very easy to solve.